Greetings, medics! Welcome to the quantitative reasoning section for UCAT, where we're going to be going through some worked examples for speed, distance, and time calculations. Let's get cracking. Question number 1. Right, it looks horrible because there aren't many words, and therefore it probably is. So 2 couriers leave the same hospital A for hospital B at the same time. One is traveling at 50 kilometers per hour and the other is going faster at 60 kilometers per hour but leaves 20 minutes later. Our job is to find out at what time the faster courier catches up. Okay, so let's break this down step by step. Okay, so we can label them courier 1 and courier 2. So let's call this courier 1 and let's call this courier 2. So courier 1 starts 20 minutes before courier B. And we know that the speed they're doing is 50 kilometers per hour and the time period is 20 minutes because they start 20 minutes before courier B, right? So 20 minutes is exactly 1/3 of an hour. So straight away we are thinking, let's work out the distance covered by courier 1 in that 20 minutes. So it's the speed times the time. So let's get our calculators, obviously. So 50 over 3 is 16.67 kilometers. Okay, so now let's have a look at courier 2. So courier 2 starts, so the time that courier 2 starts is 10:20. And by that time, courier A has already traveled 16.67 kilometers. So let's just get this down. So by the time courier 2 starts, courier 1 has traveled 16.67 kilometers. What about courier 2? Courier 2, 0 kilometers. Haven't covered any distance at all. So where do we go next? So we can picture this as they're both starting now from 10:20. Okay, so we've counted for that first 20 minutes, so they both are setting off at 10:20. So imagine they both set off at 10:20. Okay, so we know that courier A or courier 1 is ahead by 16.67 kilometers and courier B starts at 0 kilometers. Now they eventually meet at the same point. Now if they're meeting at the same point, they must have traveled the same total distance by the time they meet. Okay, that's a really, really key point. So they meet at the same point, so must have traveled the same distance because they're leaving from the same place, right? So the time they meet, they must have traveled the same distance. So we need to build some expressions for distance here, okay? So that's the setup. Let's have a look for courier 1. Okay, so we know that from that point, we can say that the distance is going to be, from 10:20, I guess, it's going to be 50 times t, which is time here. But remember, they've also covered some distance in the first 20 minutes. So we have to account for that. So we're just going to add that on. Okay. So this is going to be 50t plus 16.67 kilometers. Okay, so that's courier 1. And then courier 2, when they leave, remember their distance is going to be their speed, which is 60 kilometers per hour times time. So that's going to be 60t. So remember, they meet at the same point. If they meet at the same point, they're going to have covered the same distance. So that's going to be distance for courier 1. That's going to be distance for courier 2. But let's set them equal to each other. So if we set them equal to each other, because they're meeting at the same point, we can then say that 50t plus 16.67 is equal to 60t. Okay, now I'm guessing it's a thing of just moving the t's around. So if we take 50t off both sides, that becomes 10t is equal to 16.67. So then if we divide by 10 on both sides, we can then say that t is equal to 16.67 over 10. Okay, so 16.67 divided by 10 is 1.667 hours. So that is effectively 1 2/3 is equal to my time. From that 10-20 point onwards, right? So that is telling me that 1 2/3 hours equals 1 hour 40 mins. So where do we go next? So 10-20 plus 1 hour 40 mins is going to take me to 12 o'clock p.m. and done. What a juicy question. Okay, question 2. A nurse walks between 2 wards 1.2 kilometers apart in 18 minutes. On her return trip, she walks 25% faster. How long does the return trip take? Okay, so let's look at the first journey. So speed is distance over time. So step 1, speed is going to be the distance, which is 1.2 kilometers over the time taken. We can leave it in minutes here. So let's see how many kilometers they cover per minute. Let's get the calculator up. So 1.2 kilometers covered in 18 minutes. So per minute, what is that? It is, we'll leave it at 0.0667 kilometers in 1 minute. Okay, we can leave the calculator up. We're probably going to need it. So then, step number 2. So on point number 2, on the return trip, they walk 25% faster. So the original plus the 25%, let's call that 125% of the original. So on the return trip, they are doing 125 over 100 times the original, and the original speed was 0.0667. So we're timesing it by the original. So what do we get? So there's the original. I'm going to times it by 1.25, and we should get 1/12. Okay, so that is 0.083 kilometers per minute. Now, don't just think that's the answer, because it's saying how long does the return trip take? Now, the distance between the two wards is 1.2 kilometers. So that's the distance, and we know the speed when she's walking a bit quicker. We have to determine the time. So the time taken is the distance divided by the speed. So the distance is 1.2 kilometers all over the speed, which is 0.083 kilometers per minute. So what we're going to do is 1.2 over the answer. So we should get a time in minutes of 14.4. And that is the answer. Very good question. Okay, question number 3. Obviously, a medication van drives at 60 kilometers per hour but must detour on a slower road for 30 kilometers per hour. And for this distance there in meters. So straight away, I'm thinking, let's convert that into kilometers. Okay, so if we divide that by 1,000, that is going to be 15 kilometers. Okay, so what is the total time to complete the 75-kilometer journey? Okay, nice. So let's work with the slower road. They are traveling at a speed of 30 kilometers per hour for that distance, which is 15 kilometers. So what can we work out? We can work out the time period, okay? So step number 1, time on the slow road. So time on the slow road is going to be, so speed equals d over t. So time is equal to the distance divided by the speed. So the distance was 15 kilometers and the speed was 30 kilometers per hour. So this is 1/2 or 0.5 hours. Or 30 minutes on the slow road. Now, the question tells us that it's a 75-kilometer journey in total, and we've covered 15 kilometers of those on a slow road. So distance covered on the fast road is 75 take away 15, which leaves me with 60 kilometers on the fast road. So then the last thing to work out is the time on the fast road. Remember, it says total time, so I will account for that. So the time on the fast road is going to be the distance, which is 60 kilometers, over the speed. And they were doing 60 kilometers per hour on the fast road, so that is 1 hour on the fast road. So finally, it's saying what is the total time to complete that journey? Well, we need to add up 1 hour and half an hour, or 30 minutes. So the total time is 1 plus 0.5, or 1 hour and done. What a lovely question. Thank you for watching. Ta-ta.